This video is going to cover some of the basics. We are going to get into factoring, and so in this video we're going to cover some basics that you need to know before we get into factoring. First of all is distributing, which I think we all know how to distribute, but just remembering some important things about the exponents. If you distribute this, you're going to get negative 18r squared. Make sure that you know that r times r is r squared, and then a negative times a negative is obviously going to be a positive 10r. Same thing down here, we just have a little bit higher degree of the powers, and so 5 plus 4 is 9, and 5 plus 2 is 7, and then this one is just going to be a positive 12m to the fifth. So make sure you understand how to distribute and also how to deal with those exponents. Take a second now, pause the video, and try to do the next section and see what you can come up with on the next section. Okay, in this section, there are two different ways you could do it. You could go over to the right and just distribute this and see what that comes out to. So that one's going to be 5x to the third plus 10x, and then come over here and match it with whichever expression on the left that it matches to. That would be one way to do it. That would be kind of a long way, but you could certainly do it. I think a more efficient way would be on this side, on the left-hand side, look to see what your GCF is. So we have a 4x over here that I know I can factor out, and that leaves me with a 2x minus 3. And so then I can go and find that one and match it up that way. Either way is acceptable, but the important thing that I want you to remember here is that factoring is the opposite of distributing. And so if you have factored something, you should be able to distribute it and get the same answer you got from it before. So make sure you understand how all of these 5 examples are working. A couple of sentences here just to enforce some of these concepts. Factoring a polynomial reverses the multiplication process. In order to factor a monomial from a polynomial, first you must find the greatest common factor of all the terms, and we call that GCF. After you find the GCF, you now need to finish factoring the polynomial by dividing all of the terms by the GCF. When you are done, there should be no common factors except for one. So let's look at some examples. With number 5, I can look at this and I can see that my GCF is 5. If my GCF is 5, that means I'm going to divide each of these, divide by 5. And so I'm going to put my 5 on the outside. I divide by 5, I get 3x squared. I divide by 5, I get 2x, and I divide by 5, and I get 5. So that would be the factored form. Number 7 is a little bit more complex because it has x's and y's, and it has a lot more in those x's and y's, a lot more exponents. So again, if I look at it, I need to find my GCF. Well, my GCF on this one is going to be 4. And then if they all have an x, which they do, I need to include the x, and the power of it needs to be the lowest power that's listed because that would go in to everything, and so x is the lowest power that's listed. Each of them also has a y, so I need to list my y, and I need to list the lowest power listed. This time the lowest power is a second power, so I want to include that. Now that I've got that, I can factor out my GCF. I put my 4xy squared on the outside, and then I divide. And when you divide, your powers, you subtract. So x to the third minus 1 is x squared. Y to the fourth minus 2 is y squared, and so forth. So you are subtracting each of these as you go. Okay, on this page we're going to be talking about the double distributive property. Some people like to call that FOIL, and some of you might have heard the phrase FOIL before. Sometimes I use FOIL, but sometimes I just call it double distributive because that's a little bit more indicative of what we're doing. Some of you have learned the box method, and if you have learned the box method, then this is when you would use that box method. Remember to set up your boxes. You put 2x minus 3 on one of the sides, doesn't matter which one, and then the x plus 5 on the other side, and then you multiply to get each box. Now remember also that when you do that, you then have to combine like terms with these terms here. That is something you probably learned in middle school, and it's okay, it's fine. It's just a little bit elementary. By the time we get to Algebra 2, we kind of want to move on from the box method to something a little bit more efficient. And so the FOIL method is a little bit more efficient. FOIL stands for first, outer, inner, last. I use that phrase sometimes, but really I try to use the double distributive more frequently. Because double distributive tells us what we're doing. We're going to take that 2x and we are going to distribute it to both of those. And then we're going to take the 3 and we're going to distribute it to both of those. Now our answers come out the exact same as they would in the box, but it's just a little bit less space and a little bit, I don't know, it just looks a little bit more advanced, I think. And so then we still have to combine our like terms, so we add those up to 7x. So this is our answer, 2x squared plus 7x minus 15. Let's look at a couple more examples. So here is number 1. If we double distribute, we're going to multiply the 4a times the 3a, the 4a times the 6, and then the negative 5 times the 3a, and the negative 5 times the 6. So in our first step, we get 12a squared plus 24a minus 15a, and then minus 30. And of course, we can combine those inner terms, those two middle terms, and they combine to be a positive 9a. When you are doing this and you're moving along, if you start getting pretty good at it, I don't actually need this first step. If you're able to combine those in your head without showing that work, I'm okay with that. The next example, once again, we're just going to multiply, double distribute. We get 7x, 21, x squared, and 3x. But we do want to rewrite it into standard form. So we do need to combine our terms. We have a 7x and a 3x, but we also want to write it in order. That is, we start with the highest power and we work our way down. So it's x squared plus 10x plus 21. It does need to be in the correct order. This next example, number 5, you know that when you have a power, that power means times itself. And so we're going to write this out as x plus 5 times itself. And so we can just, now that we've written it out, we can just multiply it out by FOIL and double distribute and get our answer. So we can do that. Now, there are some rules that you can memorize. We are not going to memorize those now. I don't really think you need to memorize them ever, but some of you have probably learned them and memorized them, and that's fine. So just mentioning that you might want to do that, but I'm not really going to focus on the memorizing. I think if you learn the process, that's more helpful. This next example is similar to the last one we did. The only difference is we have a minus here and a plus here. And so when we multiply them, we're going to add our like terms, and when we add the like terms, something is going to happen that's going to make it look a little bit different. So let's go ahead and multiply those out. And when you multiply them out, you get x squared plus 3x minus 3x, and then minus 9. And if we add our plus 3x and our minus 3x together, they cancel out. And so our final answer does not even have an x term or a b term in it. It's just x squared minus 9. That happens anytime you have a plus and a minus. That is a special case called the difference of squares. And the cases up here is also a special case called the square of a binomial. Think about those phrases and what they mean. A binomial to the second power is the square of a binomial. Here, the difference of squares, we started out with a perfect square minus a perfect square. That means a difference. Minus means difference. So square minus square is called the difference of squares. On the next page, we have a matching section. So take a second right now, pause the video, and see what you can do on matching. There are two different ways to match them. You could start on the right-hand side and multiply them out, but the shorter way is to start on the left side and see if you're able to factor them. So pause here and see what you can do on factoring those trinomials. Okay, here are the answers. Take a second to check your answers. Do you have the same thing that I have? In the next part, it asks you to write some observations that you found about factoring a trinomial. So I want to just go back to what I was saying before, which is that you can multiply each of these out. So you're going to get x squared plus 5x plus 3x plus 15. Now you can do that, and that's going to give you x squared plus 8x plus 15. But that takes a while. And there are some shortcuts here. So we have this 15 and the 56. What did you realize about the 15 and 56? Or 7 and 12. What did you realize about the 7 and 12? Take a few minutes to kind of gather your thoughts, and in the space below, write down what are some things that you could do to make this shorter. Instead of having to multiply everything out, what are some shortcuts that you have? Okay, the way I wrote this, and this may or may not make sense to you, I'm going to try to explain it along the way. So whatever you have written is fine. But here's what I have, is if the trinomial is called ax squared plus bx plus c, and then over on the right we have these other terms, let's call them x plus m and x plus n. Then what I'm trying to say is you can look at the m and the n, and if you add m and n together, they should add up to b. And if you multiply m times n, it should multiply to bc. That's the first thing that I'm going to talk about. Let me take a minute to explain that up here up above. Okay, I'm going to look at some of these examples and try to explain that rule I was just talking about. So if you look at some of these over on the right, let's just take a look. I'm going to try to pick one. Let's take C, for example. If we have a negative 10 and a 4, well, we want to look at what is negative 10 plus 4, and we also want to look at what is negative 10 minus 4. And so as we look at each of those, now we have our answers of what should be over in the trinomial. That is the m times n, or the negative 10 times 4, the negative 40, that should be the number on the end. Well, there's a negative 40. Are there any others that have a negative 40? Here's a negative 40, and those might be the only ones. Okay, so those two have a negative 40. The other thing is that when I add them together, I get negative 6. Well, this one has a positive 6, but this one has a negative 6. So example C should go with number 10 because they multiply to be negative 40 and they add to be negative 6. That is the shortcut. And we're going to start working towards factoring, and all of these are just basic examples of factoring. The other thing is to pay attention to plus and minus signs, and we had that just a second ago as well, that we had a negative 6 and a negative 40. So we weren't just looking at the 40 or just looking at the 6, we were looking at the signs as well. And so we had to be really careful in choosing which one depending on which sign we have. If you have other things written down here, that's fine. This is space for you to write down whatever you can do to help you with some shortcuts. Make sure they're accurate shortcuts. Okay, on this page, we are going to be practicing some of that skill that we just talked about. In the margin, remember, factoring is the opposite of distributing. So that's basically a way you can check your answer. What I like to do here is think about what numbers could multiply to get 14. Well, we could multiply 1 times 14, or 2 times 7, and those are really the only options. We have some negative options. We could do negative 1, negative 14, and negative 2, negative 7, but since we have positive numbers here, we don't really need the negative options. So these are our options. Now we think about, okay, well, which ones add up to 9? Well, the 2 and the 7 add up to 9. So that means that when we factor this, it's going to be x plus 7, x plus 2. And these sets of parentheses can go in either direction. It does not matter which one comes first, which one comes second. Let's look at the next one, 21. Well, if we break down 21, we could say that's 7 times 3, or it's 1 times 21. Either one of those, they're all positive, so we're sticking with positive. We want to add up to the middle. Well, that's going to be 7 and 3, isn't it? So our answers are going to be x plus 7, x plus 3. And again, they could be in either order. Last example, this time we have a negative 21. And so we want to pay attention to that negative this time. We didn't really pay attention to the negatives, but here we need to because we have a negative 21. So that could be a negative 3 and a positive 7, or a negative 7 and a positive 3, or a negative 1 and a 21, or a positive 1 and a negative 21. We have more options. We need to find out which ones add up to a negative 4. Well, it's not the 21 and 1s. Those don't work. This one, the top one that I have, adds up to positive 4, but we're not looking for positive 4. We are looking for a negative 4. So that is a negative 7 and a positive 3. When we put that into our parentheses, it's x minus 7 and x plus 3. Now, I have over here that the factoring is the opposite of distributing. So if you wanted to check your answer, you could multiply these out. That's x squared plus 3x minus 7x. Well, plus 3 and minus 7 gives me a negative 4, which it's supposed to, and then minus 21. So the fact that factoring is the opposite of distributing helps us check our answers. Okay, this section is kind of messed up. There's a bunch of typos here. When I did the typing, I wasn't able to edit what I needed to edit. So let me just take one of the examples and show you how we're going to do this. Number 20, I'm going to take number 20 and just cross out this other stuff over here. We need to look for a GCF. The GCF is 5. If I factor out of 5, I get x squared plus 4x plus 4. Now that I have that trinomial, I need to factor that trinomial down. So when I factor that, I have to think of what multiplies to be 4 that adds up to be 4. Well, 2 and 2 multiply to be 4 that add up to 4. Your answer, you could either leave it in this form, or you could say 5 times x plus 2 quantity squared. Either one of those answers would be fine. I like this last one better, just because it shows me you know what's going on, but this one over here is fine. Okay, so special cases, we have done a couple of special cases throughout this lesson. We just haven't called them special cases. If we think about number 25, there's no x term in the middle, right? But we could put a 0 there. And so now we're thinking of what numbers multiply to be negative 49 that add up to 0. Well, the numbers that multiply to be negative 49 that add up to 0 are negative 7 and 7. And so when we factor that, we're just going to have x plus 7 and x minus 7. That is one kind of special case. Do you remember what this is called? We have a square minus a square. That's called a difference of squares. Okay, number 27 is not a difference of squares. It's a little bit different. It'll turn out to be kind of a special case, and you'll see why. We need to look at positive 16 and think of what numbers can we multiply to be positive 16 that would add up to be negative 8, and that would be negative 4. That would be negative 4 times negative 4. And so our answer, I've already abbreviated it. You could write it as x minus 4 times x minus 4, or you can just abbreviate it like this, x minus 4 quantity squared. And I prefer that x minus 4 quantity squared, but this one over here is not wrong. The last example looks a lot harder because it has this number in front, and we haven't really talked about that. But let me tell you what's going on is these are still perfect squares. Perfect square minus a perfect square. And I don't know if you've noticed what we're doing here. The square root of x squared is x, and the square root of 49 is 7. Same thing on 27. Square root of x squared is x. Square root of 16 is 4. And so on number 29, that's what we're going to do. The square root of 121x squared and the square root of 25. Well, the square root of 121x squared is 11x, and the square root of 25 is 5. And because it has that 0x term in the middle, it's not shown, but there is a 0x inside there, then this is a negative 55, this is a positive 55. Those drop off. And so this is my final answer. This is a difference of squares. Number 27 was a perfect square trinomial. Those are what's special about those special cases. Okay, that is the end of this lesson. This was information that you should have already learned. We need to review a little bit, so we did get some review in, but we will be moving towards slightly more difficult factoring later on this week.